Hello people, in this video I'm going to show you my instruction set that I have just came up with. It is 16 bits and it's somewhat slow, but it gets the job done and I think it's pretty efficient in terms of bits and pretty straightforward, and anyone can actually use it that does not have so much experience with this instruction set stuff. Now, I want to apologize from the shaky camera, but I have little or no control over it, and I'm sorry for that. Now, let's get started in these operations. First off, we have this ALU operation selector, which is 3 bits, and as you can see on the screen right now, 0 add, 1 subtract, 2 or, 3 XOR, 4 and 5 NAND, 6 branch if A equals B, 7 branch if A bigger than B. And these are pretty straightforward and pretty much everyone else knows. And we have this memory part. I don't know if it has an appropriate name for it. I just use memory management, maybe, I don't know. It's 5 bits, and the first part is memory operation selection. It's 1 bit, 0 read, 1 write, pretty straightforward. Destination selection, it is 1 bit as well, 0 read or write from the main bus, 1 is the program input, which I'm going to cover here. Now here we have our address selections. It's 3 bits. We have 4 general purpose registers, 4 RAM addresses. Now if you wanted to write some programs like very simple addition programs like Fibonacci numbers and stuff, we wouldn't be able to do it like it is right now. So I assigned these GPRs and RAM addresses as real registers or buffers in the hardware. So GPR 1 will be user interface output panel, like it's very see and outputs. GPR 2 will be ALU output register. GPR 3 and 4 will be ALU inputs 1 and 2. But as I said, you are not like restricted into these purposes. You can store any data you want. And it's the same thing as RAM goes. RAM addresses A and B are user inputs A and B, and it's where they stored at first, and you can just use them and start your program and use those RAM and A and B for something else. Moving on, we have this 8-bit value inputs panel. Now I'm just going to read this thing in brackets here, which is terribly written because of my handwriting. So here's how it goes. Now, if we have given a branch here in the ALU operations, like these two, pick up pencil here, like branch equal, branch bigger. If we have selected one of these in the ALU operations, then the value we enter here would be just this part. This part will be the line selection, and the other 3 won't be used. And if we didn't give any branch commands, then and it's just a value that you can write into these either general purpose registers or RAM, and you select it from here. Main bus is like where data flows, and you can just pull data from that bus and save it to GPR or RAM. But the program input, which is this 8-bit value here, you can save this value here, either of these GPRs or RAM. So it's pretty awesome. So you can have constants going on, and you won't need any ROM, which is good. So actually, these conditions act as opcodes for the values here, and I might try to find something to do with these 3 bits, because I mean that makes 8 unused code, which makes it pretty inefficient. But generally it is completely an efficient design here, and we use all the bits possible here. But the missing 8 value here, I don't know, I might find something. And so yeah, so again, sorry about this shaky stupid camera I'm holding. and if you actually want the name, it's URS XX 16.0.3, which stands for Ultimate Ready Instruction Set. XX stands for Riot Xander, which is my in-game name. Sounds pretty weird. In-game name, okay. 16 stands for the bit number. All this instruction sets 16 bits. 0.3 is the version, and this is the 3rd version I make this instruction set. I'm gonna throw C in this yours, so it becomes your risk. Sounds amazing. Okay. So, and yeah, thanks for watching, people. I will see you in the next video. If you have any suggestions, or if you just want to tell something, you can either go to Twitter or comment it below. So thank you. I'll see you later.